In this illustration, we are given three identical electric dipoles arranged parallel to each other, 1, 2, 3, at equal separation as shown in the figure. That means the separation between dipole number 1 and 2 is same as the separation between 2 and 3. Also, it is given the separation between the charges of the dipole is negligible as compared to the separation between the dipoles. That means the separation between the positive and negative charge is much smaller than this distance. That means we can apply the formula of the electric dipole. In next part of the question, we are given in the given configuration. That means when all three dipole moment vector are parallel to each other, the total electrostatic interaction energy is U naught. That means at this configuration, total energy is U naught. Now what is done? Now one of the end dipole, either 1 or 3, is gradually reversed. How much work done by the electric forces? We need to calculate the work done by the electric forces when either 1 or 3 is gradually reversed. Okay, so let us make the diagram to the next page. This is the situation. Okay, we have written dipole moment vector P1, P2, P3 for 1, 2, 3 dipole, and here it should be noted that P1 vector is equal to P2 vector equal to P3 vector, because dipole moment we have the identical dipoles. Okay, and separation say small r and small r. And if we take 3 dipole as a system, we will have the 3 pairs. That means we can write the potential energy of the system as U12 plus U23 plus U13. This is the potential energy associated with the 3 pair of the dipoles. Okay. Now let us consider potential energy of 1 and 2. So let us write U12 and U12 equal to minus P2 dot product E1 vector, right? Potential energy associated with the second dipole because of the electric field of first dipole. So we have written minus P2 dot E1. E1 is the electric field associated with the dipole number 1. We can observe here the center of the dipole of number 2 is at the equatorial position of the dipole number 1. That means the electric field because of this dipole should be in the downward direction. So let us assign this vector as E1 vector. Now we can observe the angle between P2 vector and E1 vector is 180 degree or pi. So here we can write this dot product as P multiplication K P divided by R cube. R cube is the separation, R is the separation between these two dipoles, and multiplication cos 180 degree. And cos 180 degree equal to minus 1. So this is equal to minus minus will be positive. So this value will be K P square divided by R cube. This is U12. Similarly, we can write U23 because we can observe the configuration is similar. That means the potential energy U12 should be equal to U23. So this is the potential energy for 2-3 configuration. Now we can observe for 1-3 we have identical method, identical process. Only difference is the separation. Instead of R we have 2R. So instead of R we should substitute 2R, and if we substitute 2R, this value will be equal to Kp square divided by 8R cube. So U13 is equal to Kp square divided by 8R cube. Okay, so we calculated the potential energy associated with 1, 2, 2, 3 and 1, 3. So let us substitute in this expression, this one. So we got this relation. Now we can add these values. This is equal to 17 Kp square divided by 8R cube, and we are given the initial potential energy, that is the potential energy associated with the initial configuration is U naught. That means this value is equal to U naught. This is the U naught. Now from this we can find the value of K P square divided by R cube. This is equal to 8 U naught divided by 17. Let this equation number 1. Now let us move to the next part of the question. In next part of the question, we are given now one of the n dipole is gradually reversed. So let us reverse the direction of dipole number 3. So let us make the diagram, right? This should be like this. Okay, now we can observe here. Again we have the 3 pairs because the system is having the 3 element. So we can write the potential energy is equal to U12 plus U23 plus U13. This is the potential energy. And here we can observe these 2 dipole 1 and 2 are parallel, and but 2 and 3 are anti-parallel, having the same dipole momentum P and same separation. That means U12 and U23 will have the same magnitude but opposite direction. So if this is positive, this will be negative. That means these two will get cancelled. Okay, that means the total potential energy associated with the system should be equal to U13. That means we need to calculate U13 now. Now select 1 and 3. We can write this potential energy as P minus P3 dot product E1 vector. P3 is the dipole moment of the third dipole, and E1 is the electric field associated with the first dipole at the center of the third dipole. We can observe again the center of this dipole at the equatorial position. That means the electric field because of this will be anti-parallel to the P1 vector. That means it will be in the downward direction like this, E1. And we know the formula for the electric field because of this dipole as Kp divided by 2r to the power 3, because separation is 2r. So here we can write, and we know angle is 0 degree between P3 and E1 vector. So we can write this expression minus P multiplication E1 vector magnitude multiplication cos 0, right? That means it is equal to Kp square divided by 8r cube. This is the total potential energy at final configuration, this one. Now we can write the burden by the electric force equal to minus of the change in potential energy, and we know potential energy change is equal to U final minus U initial, and we know the value of U final this one and U initial was this one. So let us write this U final minus U initial. Now we can simplify. This is equal to 18 Kp square divided by r cube, and we have calculated the value of Kp square divided by r cube as 8 divided by 17 U naught. So let us substitute this value, and now 8 and 8 will get cancelled. This is equal to 18 divided by 17 U naught. This is the work done by the electric forces.
Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.